All right, let's talk about what really happens inside a modern data center. I mean, have you ever stopped to think about it? How does your data zip from one place to another securely and like instantly? Well, today we're going to pull back the curtain on two powerhouse technologies, Cisco ACI and VXLAN. And the best way to do that? We're going to follow the epic journey of a single data packet from the very beginning to the very end. So, here's our game plan. First up, we need to understand the world our little data packet was born into. And spoiler, it was a tough place. Then, we'll meet its guides, VXLAN and ACI. After that, we'll track its journey step by step, see why it's all worth it, and then, just for fun, we'll bust a few common myths you've probably heard.
Okay, so to really get why our hero, this data packet, is so important, we have to start with the old world, the world it used to live in.
And let me tell you, it was a world just full of problems.
And that brings us to the big question, right? The question that really kicked off a revolution in networking. Why did the old way, a system that honestly worked pretty well for decades, just suddenly hit a massive wall? Well, the answer is pretty clear when you look at the details. See, old school networks were all about VLANs. The problem? You could only have about 4,000 of them. Now, that might sound like a lot, but in today's huge multi-tenant cloud data centers, that's nothing. It's a crippling limit. And then, oh man, then you had spanning tree protocol. Its job was to stop network loops, but it did it by, get this, just shutting down perfectly good links. So you ended up with a network that was not just slow, but also super fragile. It just couldn't keep up.
So, yeah, the old world was really creaking under the pressure. Something had to give. And this is where our first hero, VXLAN, steps onto the scene.
So what is VXLAN? In the simplest terms, it's an encapsulation technology. The best way to think about it is like this. Imagine you have a letter. VXLAN takes that letter and puts it inside a brand new, much smarter envelope. It wraps the original packet in a new header, which lets it travel over a basic, sturdy IP network. It's literally creating a virtual tunnel just for your data.
And this is the absolute game changer. Remember that old limit of 4,000 VLANs? Well, VXLAN just blows that completely out of the water. We're talking about support for up to, wait for it, 16 million unique network segments. They're called VNIDs. Now that is the kind of scale you need for modern data center.
But here's a really crucial point. You have to get this right. VXLAN is the powerful vehicle, right? It's the transport. But it's not the whole story. Something still needs to tell it where to go, what to do. Something needs to be the driver. And that's where Cisco ACI comes into the picture.
Exactly. If VXLAN is the transport, then ACI is the brain. It's the intelligence, the policy engine that dictates all the rules. ACI tells the network exactly what to do, who's allowed to talk to whom, and how everything should be connected. You know, this quote just perfectly nails the relationship. VXLAN provides the transport. ACI provides the meaning. It's so simple, right? VXLAN builds the roads, those virtual tunnels, but it's ACI that puts up the road signs, the traffic lights. It gives the whole system purpose. It provides the meaning. Okay, so how does ACI actually translate that meaning into action? Well, take a look at this table and zoom in on that fourth row. This is the key. In ACI, you don't think about IPs and MACs as much. You think in terms of applications, and you group them into what are called endpoint groups, or EPGs. And here's the magic. ACI automatically takes each EPG and maps it to a specific VXLAN VNID. That right there is the magic link. It connects the business policy, what you want to happen, directly to the plumbing of the network. All right, the stage is set. We know the old, broken world. We've met the vehicle, VXLAN, and we've met the brain, ACI. So now, let's follow our hero packet on its big journey through the ACI fabric. So here's the setup, nice and simple. We've got one virtual machine, let's call it VMA, and it's in our web EPG. It needs to send some data over to VMB, which is in our app EPG. And crucially, we've told ACI that this is allowed. There's a policy called a contract that gives the green light for this conversation. Okay, let's break this down. Step 1. VMA sends out a completely normal Ethernet frame. It has no idea there's anything special about the network at all. Step 2. That frame immediately hits the first switch, which we call the ingress leaf. This is the security checkpoint. The leaf checks the policy and asks, is the web group allowed to talk to the app group? The contract says yep, so access granted. Step 3. Now that it has permission, the leaf does its magic. It takes that original frame and wraps it up inside that new VXLAN envelope we were talking about. Step 4. The packet then hits a spine switch. Now, the spine doesn't care about what's inside. It's just like a super efficient postal service. It looks at the new outer address and boom, forwards it on at lightning speed. And finally, step 5. The packet arrives at the destination switch, the egress leaf. This leaf unwraps the VXLAN package, pulls out the original frame, and delivers it safe and sound to VMB. And just like that, the journey is complete.
Now, this is maybe the single most important thing to understand about how ACI works. The security policy is enforced right at the beginning, at the edge. The very first switch the packet touches makes the decision. Think about that. If that contract wasn't in place, if web wasn't allowed to talk to app, that packet would have been dropped right then and there. It would never have even made it into the main network fabric. Security is built in, not bolted on.
So now that we've seen how it all works, let's get to the big question. Why? What's the payoff? What are the real benefits of sending our packet on this cool, efficient journey?
Really, it all comes down to 3 huge wins. First, scalability. It's massive, all thanks to those 16 million VXLN segments. Second, speed. It's just incredible because those spine switches in the middle are doing one simple thing, routing packets as fast as possible. And third, security. Like we just saw, it's baked right in, enforced at the edge by the leaf switches before anything bad can happen.
And it's super important to make a distinction here. This isn't the same as just setting up a VXLAN network by yourself. If you do that, you're the one manually mapping everything, setting up control planes. It's a lot of work. With ACI, all that complexity just vanishes. It's abstracted away. You just tell ACI what you want to achieve. I want web to talk to app, and ACI figures out how to make it happen. And that is the real game changer for network teams. It means you can roll out applications faster, you slash the chances of human error, and you finally have a network that actually understands what it's running.
Okay, to wrap things up, let's do a little myth busting. I want to go through a couple of common misunderstandings about ACI that honestly trip a lot of people up. This will be good for your next job interview, trust me. Okay, myth number 1. You hear this all the time. The spine switches, the big core routers, they must be the ones enforcing all the security policy, right?
Nope, absolutely false. Remember our packet's journey? The spines are just the super fast postal service. All the brains, all the policy decisions, all the security enforcement, that happens on the leaf switches, always at the edge of the fabric.
All right, how about this one? Myth number 2, ACI is just a fancy marketing term for the same old switching. It's just using VLANs in the background.
Yeah, that's also completely false. Look, you might use a VLAN to connect an old server to a leaf switch at the very edge. But the second that packet enters the fabric, the communication between all the switches, that is pure VXLAN. It is a fundamentally different and way more powerful architecture.
So there you have it. We've seen how ACI uses VXLAN as its transport to build a network that's incredibly scalable, super fast, and secure by design. But the real power isn't just in the tech itself. It's in what you can do with it. Which leads me to a final question for you. Now that you know the how would you use these tools? How would you use EPGs and contracts to build the perfect, most secure, most efficient data center for your own applications? Because that's where the real fun begins.